Hey guys, Mrs. Rona here. I'm going to talk you through these scenarios. So now we are going to start doing vertical motion. So not just right and left, but up and down. So scenario one, we've got an elevator. Here is the picture of a person in an elevator that's being hung by a cable. And so it says a 400-kilogram elevator is waiting at the top floor of a building. Underline the words above that lead you to believe the forces are balanced or unbalanced. So I would circle or underline waiting because that tells me that it's balanced, right? We know things at rest have balanced forces. So let's go ahead and draw the free body diagram. So you make your box. Now with elevators, there's no surface, right? The elevator is hanging in the elevator shaft. And so we would have weight, Fg, but what's going up is the tension. Okay, so you wouldn't put a surface in, you wouldn't have a normal force, we have tension. Now these two are equal because it's at rest. Horizontally, F net x, you can assume there's no friction, that nobody's pushing the elevator right or left. Elevators generally just go up and down. So we can say there's nothing in the x direction. And in the y direction, we have Ft minus Fg. And as always, we can set that equal to ma. Now I'm going to call that may so that we are clear that we're talking about vertical motion here. In terms of these directions, well, it's not moving, so velocity is 0, acceleration 0, the forces are balanced, so F net is 0. All right, so it says calculate Fg of the elevator. Write the equations you use in variable form first. So remembering that Fg is equal to mg. Fg is the force of gravity or weight. M is mass, G is gravitational field strength. So they tell us the mass up here is 400 kilograms. So I'm going to say 400 times G is gravitational field strength on Earth. That's 9.8. And so what we get is 3,920 newtons. And we always want to say which way the force is going. So Fg is pointing down. Part C says use your net force equation in the vertical direction to calculate Ft. Write the equations used in variable form first. Some of you are like, Mrs. Rona, we know it's 3920. They have to be equal because there's no F net. But how would we show that with an equation? So we would use what we wrote here. So we're just going to take that equation you wrote and rewrite it down here. So Ft minus Fg is equal to may, right? Because net force is always equal to ma. And so we're solving for Ft, so I'm going to leave that there. Fg is 3920. The mass is 400. And the acceleration is right here in this diagram. We said it was 0, so we can plug in a 0 for that. So Ft minus 3920 is equal to 0. Anything times 0 is 0. And then we can add 3920 to both sides. So plus 3920 plus 3920. And you're going to get Ft is equal to 3,920 newtons because it's a force. And then we want to add a direction. Tension is going up. All right, so not too bad. Very similar to what we did before. Let's try the second scenario together. All right, so here, an elevator speeds up at a rate of negative 1.5 meters per second squared, moving downward. So underline the words that lead you to believe the forces are balanced or unbalanced. I would underline speeds up, right? You could also underline the acceleration, but we know that when things are changing their speed, that the forces are not balanced on them. So let's draw the free body diagram. Elevator has Fg. Again, there's no surface, so there's no normal force, but it's going to have tension. Now I need to decide, is tension bigger or smaller than Fg? And what I'm going to think about is if it's speeding up, moving downward, I'm going to go over here to my arrow. So moving downward, that tells you your velocity. Velocity is down. Speeding up, we know, means that velocity and acceleration have to go together. So instead of right or left, we can go up or down over here. And we know because of Newton's second law that if you have a downward acceleration, you also have a downward net force. So how is it possible that downward net force? Well, it means tension must be smaller than the force of gravity. Now, one thing I want you to think about, if this elevator was at rest first and now it's moving, did the Fg get bigger, right? Did the earth pull harder and that's what made the elevator start moving? The answer is no. Fg is equal to mg. It's going to be constant for this elevator. The elevator didn't get more mass. We didn't change the earth, so 9.8 is still the same. In order for an elevator to move down, accelerate down, this tension would have to let up. So before they were equal, now we have less tension because it's starting to accelerate downward. I just don't want you thinking that Fg changed. Fg should stay the same if it's the same elevator. Ft would change. In this case, it's a different elevator, but know that Fg is based on mass and gravitational field strength. All right, F net x is 0. We've got nothing right and left. In the y direction, it would be the force is up minus the force is down. And again, we can set that equal to ma in the y direction. And so it says calculate F net y. So looking at what we're given, we are given the mass and we're given the acceleration. So we're just going to use F net y is equal to ma_y. And so we know the mass is 500, the acceleration is negative 1.5. And so we can put those together and we get negative 750 newtons. And we want to say which way is the net force. Well, looking up here, the net force is down. So this negative 750 wouldn't go on your diagram. It's not Ft, it's the net force. So now part C wants us to solve for Ft. So now I'm going to use my equation here that I wrote. So let's rewrite that again. Ft minus Fg equals may. Ft is our unknown. Fg, I don't know Fg, so we're going to have to pause real quick and go over here and calculate Fg. Fg is equal to mg. They give us the mass, so I can say m is 500. G, because this elevator is on Earth, is 9.8. And so 500 times 9.8 is 4,900 newtons. All right, so I can plug that in over here. 4,900 is equal to mass is in kilograms, so 500 times AY is negative 1.5. We also already did that, so if you want to plug in negative 750 there, you can totally do that. So Ft minus 4,900 is equal to negative 750. Add 4,900 to both sides. And your tension force is equal to 4,150 newtons. And we want a direction, so tension is up. All right, we'll do one more and then I'll send you off on your own. So let's look at scenario 3. An elevator that is moving down has a weight of 5,000 and a tension of 5,000. So underlining the words that lead you to believe forces are balanced or unbalanced, well, if weight and tension are equal, that tells me the forces are balanced. So let's draw our free body diagram. We have Fg, we have Ft. Remember, no surface, so no normal force. Now you might be thinking, wait a minute, isn't this object at rest? Well, remember back to Newton's first law that when forces are balanced, you could be at rest or moving at a constant velocity. So this object's moving, because it says moving down, at a constant velocity. So F net x is 0, no forces right and left. F net y is Ft minus Fg. Set that equal to ma in the y direction. Velocity we know is down because it says moving down. Acceleration, we don't necessarily know, but let's look at our F net. Looking at this picture, we said it's balanced, so F net is 0. And Newton's second law tells us that if F net is 0, acceleration must also be 0. So part B says calculate acceleration. You're like, Mrs. Rana, it's 0. We already know it's 0. So how do I prove that with an equation? Well, let's take this equation we wrote and rewrite it again. Ft minus Fg is equal to ma in the y direction. We know tension's 5,000. We know Fg is 5,000 because Fg is weight. Is equal to mass. I don't know the mass, but I could find it. So let's pause and go over here. Using Fg equals mg, I can find mass. Fg is 5,000 because that's weight. Mass is what I'm looking for. G is 9.8 on Earth. Divide both sides by 9.8, and you get a mass of 510, is that the right answer? Kilograms. So now we can plug that in, equals 510 times AY. So you get 0 is equal to 510 times AY. So AY has to be 0 in order to get 0 net force. If you're thinking, did I really need to find mass over here? The answer is no, not really. But if you didn't find mass, I would need an explanation saying like, since M is not 0, AY must be 0. Okay, so some sort of explanation that you know you don't need mass because anything times AY is going to be 0. And knowing that mass is not 0, so AY must be 0 would be okay. All right, let's try an LT3, an explanation. So the direction of the elevator's acceleration is, well, we just calculated it, it's no acceleration. So what's going on with the box's velocity? If there's no acceleration, it must be going at a constant velocity. So how would I explain that? Just like we did before, these are very similar. So describe the relevant forces as well as net force. So first one I'm going to say Ft is equal to Fg. So F net is 0. Right, that would be that first bullet point here. The second one, now I need to talk about how the net force explains acceleration using Newton's second law. So I'm going to say Newton's second law says F net causes acceleration in the same direction. So I just said F net 0. So I'm going to say since F net is 0, acceleration is 0. So that's that second bullet point. And then the last one is explain what's happening to velocity. Refer back to what you circled above. So since acceleration is 0, the object moves at a constant velocity. In this case, the object is an elevator. All right, so I want you guys to go ahead and try the rest on your own, and I miss you, and I will see you later.